Okay, so with this standard, we're just going to be doing story problems with exponential growth or decay. All right, here's our situation. You're lucky enough to have been given or you inherited $20,000 about the time you graduate high school or college, whatever it might be. Okay, so somebody gave you 20 grand. All right. And instead of going out and blowing it all right, and buying something, you decided to just invest it. It's money you didn't have anyway, all right? Let's not worry about paying off different things. Let's just put it away and let that money grow, all right? Probably not in a savings account or checking account right now because at this point, the interest rates are so low, you're not even getting 1%, okay? You're more likely to gain money if you invested in certain stocks or mutual funds or different things like that. Some safe things, you know, you're not putting it all into one company. If that company goes down and you're out your 20 grand, okay? You're investing it into safe things that's going to grow with the stock market. We've had money in the stock market for 10, 13 years, and roughly on average we get anywhere from a 4% to an 8% interest each year on the money that we're investing. Okay, it's very safe stuff. I don't even know our financial advisor takes care of all of it. Okay, but so for our instance right here, what we're going to talk about is, let's say you took that 20 grand, you invested it, and let's say on average you were getting 6% interest each year that money stayed invested in the stock market or in the mutual fund or whatever. Okay, each year. All right. Well, let me ask you this question first. How much money would you have then after 1 year?
Take 20,000 times 0.06.
Take 20,000 times 0.06 and add it to 20,000. Or take it times 1.06. Would both of those work? Okay? Absolutely. I like them both. Let me talk about what Blake said first. Okay? Blake said take 20 grand times 0.06 and then add that amount to your starting amount, your 20 grand. So you get $21,200, okay? This is what made sense to Blake to do. He's right. Find out what 6% of 20 grand is, add it to how much you had at the beginning, that's how much money you have after 1 year. And then if you wanted to know after 2 years, you'd take that amount, 21,200, so 21,200, times 0.06 plus 21,200. So you just keep repeating the process over and over again. Now this is a two-step process, so actually it would take a little bit longer to do that. Dakota said multiply by 1.06. Well, let me show you why that works. Okay? Take a look at what we have right here. Okay? Now, I'm going to, in a sense, change this to a distributive property. If I were to distribute 20,000, would it get me the exact same thing that this step does?
Yes.
Yeah. 20,000 times 0.06 plus 20,000 times 1. Is that exactly what's written up here in a sense? Absolutely. Okay? If you distribute it, you're doing the exact same thing we did up here. Add up the numbers in the parentheses. 1.06. So really, you could just take 20,000 times 1.06 and have the exact same effect as what we did up here. And that's kind of what Dakota was referencing, right? So 20,000 times 1.06 gives you 21,200. So let's say, so then after year 1 you have 21,200, and let's say you get 6% on that. So what are you going to have to do with 21,200? Times it by 1.06. Then what if you want to know for the next year? Times it by 1.06, times it by 1.06, times it by 1.06, as many times as you want to see how much money you have after each additional year, right? Or instead of just multiplying it over and over and over and over and over again, you could raise it to an exponent. And look what we have here. Y equals A times B raised to the x power. We have your exponential functions that we've been working with. Okay? Y equals A times B raised to the x power. A is your starting amount, your y-intercept, what you have at the beginning, kind of like we talked about when we first started graphing these. This is your starting amount. This is your, they call it the growth or decay factor. It's the B value, okay? If the B value is bigger than 1, growth. If the B value is smaller than 1, decay. In this instance, is our money going to be growing?
Yes.
Yes, okay, you're gaining 6% interest each year. So then, let's say you took this 20 grand and you saved it for 40 years till you decided to retire, okay? What did that 20 grand turn into in 40 years? What do you got to do?
1.6 of 40.
Raise it to the 40th power. If I want to know how much this is worth 40 years later, from the time you invested it, you just plug in a 40. 205,000. So over 200 grand. Okay? 20,000 became over 200,000 by you doing nothing. Okay? All you had to do was invest it, not touch it.
With the economy staying the same.
With the economy staying the same, you're getting the same returns. Like I said, though, I would say on average, with our experience over 10 to 13 years that we've invested, I'd say that's fairly average. It might be closer to 5%. We did have a rough stretch a little while back, but I mean, you're still getting pretty decent money on it.
And is that in stocks or?
It's in lots of different stocks, yeah. Yeah. And so, that's just with 20 grand, and that's with you not adding any money to it ever, okay? Obviously, if you have a job and you're capable of throwing extra money in a couple times a year, imagine what it would grow to then, okay? 20,000 became over 200,000. You start saving early, you'll be surprised that you can reach $1 million before you retire, if you start early, okay? $1 million seems like a lot. But if you start early, you'll be surprised. You'll be able to get there. And when you guys need to retire, you might need 1 million, 2 million, maybe 3 million if you guys are looking to be 100 and some by then. Okay? All right? Who knows? You know, of course, you might have to work till you're 75 too.
No, I was working at Casey's for the rest of my life.
It'll be a little tougher to get to $1 million, but if you're smart, Steve.
No, I got a good 401k.
All right.
I've already invested much money.
Good. That's actually very good. Okay. So, how am I doing on time?
7 minutes
7
or
I'm gonna
8.
I'm going to keep going. All right, thanks. So, this looks no different than what we've been doing. Y equals A times B raised to the x power. A is your starting amount, B is your growth or decay factor. Most of all of your story problems will use this. Y equals A times B raised to the x power. Remember, A is your starting amount. That's the easy part. A is your starting amount. It'll tell you how much you have at the beginning. Okay? A is the easy part. A is your starting amount, what we begin with. Okay? B is usually a little bit trickier. In that last instance, in the money instance that we just got done talking about, our B value was 1.06. Okay? What if the interest rate was only 3%? What would the B value be?
1.03.
1.03. 5%.
1.050.
12%.
1.12.
Okay? What if some sort of bacteria population increases by 85% every hour?
1.8.
1.85.
But that would be hourly.
Yeah, it would be hourly then. Yep, your exponent would be in hours then. Yep, if you want to know 20 hours, you put a 20 in, because 20 hours you want, it depends on the time unit. It's usually on the time, some sort of time unit, okay? So if we have something that's increasing or growing, our B value will always equal 1 plus R, where R is the rate, or the percentage. It's always 1 plus R. If something is increasing by 6%, 1 plus 6%, 1.06, okay? Something is increasing by 85%, 1 plus 85%, or 1.85. Why do we need the 1 plus?
Because then we get over it. That's growth.
It makes sure that it's growing,
Like
right?
if it was 1, like 1 minus R, that would be
That's where I'm going next, yes. If you used a B value of only 0.06 for that 6% interest, if you used a B value of just 0.06, what would happen? Decay, down. The B value is smaller than 1, it's going to get smaller. Remember how I said the B value is the number you multiply by over and over and over again? What happens if you multiply something by 1 over and over and over again? It stays the same. So if you want something to actually grow, you need to multiply by 1 plus whatever rate it's increasing by. So that's why it has to be 1 plus the rate. It cannot just be the rate. That's essentially a test question, guys. Why is it 1 plus the rate? Our discussion we just had, you will want to know. Okay? Why is it 1 plus the rate? Okay? Because you need it to grow. If you multiply it only by the rate, it will decrease in most instances. The 1 helps it stay the same, and the rate helps it increase from whatever value it started at. Okay? So make sure you're prepared for that. Question I always like to ask, what if something increases by 200%? What is your B value?
3.
3.
You had that.
Because you got to add the 1. 1 plus 200% is 1 plus 2 or 3. Okay? It's really tripling. If something increases by 200%, it's tripling. Because what if something increases by 100%? It's doubling, right? Okay? If something increases by all of itself, it doubles. All right? So if something increases by 200%, then it will be 3 of itself, or triple. Okay? All right, so that's growth. How many minutes I got till 15?
3.
Okay, I'll go fast. Decay, all right, works similar. Let's say something loses 5% of its value. What number could you multiply by to figure out how much it's worth in a year? If something loses 5% of its value in 1 year, what number could you multiply by to figure out its value? 0.95. Because if something loses 5% of its value, it's still keeping 95% of its value. If you have a 5% off coupon, okay, to go shopping, you're still paying what percent of that item? 95%, right? Okay? So decay is not 1 plus R, it's 1 minus R. Decay will always be 1 minus the rate. So if something is decreasing by 10%, you use 0.9, right? 0.90. If something is decreasing by 25% each year, 0.75. Okay? Always 1 minus the rate. That's growth and decay. All right, go ahead and pause for me.